the set. So if I write here, the set of boys, that's a mathematical statement. It is read the set of boys. Okay? Collection and the meaning is given, and you have two examples. So it said A. Now this is a mathematical sentence. Just like in English, you have English sentence. In French, Maths has its own language, right? And this is a mathematical sentence. It says the set A, capital A, the set A is the set 3, 7, 9, 14. They belong to that group for whatever reason. You group them as a set. Alright? If you don't put the curly bracket, it's saying something totally different. So if you say this is different, right? If we use wrong bracket, it's not the same thing as that. Are you with me? I'm taking time out to explain them because when you write in your answer, if you don't write it properly, you won't get any mark. You'll get it wrong. And then the next symbol is intersection. I have to go through that concept. That's an important concept. So upside down horseshoe is intersection. And the horseshoe is what? The horseshoe turn up is what? Union. And when you put the horseshoe on the side and put a dash under it. So it is saying A is a subset of set B. Okay, so let me give you an example of that. If I call this whole class A set A, and I say this set of boys. I'm using boys because of B, right? Now that I feel you all are boys. So the set of males in the class is a subset of the set A. So it's a part, the parent set, and the subset is a part of the parent set. Are you with me? Sub means it comes from the bigger one, okay? Then the next one, set A is a proper, set B, is a proper subset of set A. So the proper subset doesn't have any stroke on that. And when it has a stripe through, you say it is not a subset of this set. So for example, if I say this class is set A, the guys sitting under the gallery are not a subset of this class. They don't belong to, they're not a group of this class, right? So they're not a subset. When two sets are equal, it means they're having the same number of members. So you see in the example, set A equals the set 3, 9, and 14, and set B is the set 3, 9, and 14. They have in this exact same members. So they are equal, right? They can be equivalent, but not equal. Because if one set has in, if set A has in 3, 9, and 14, and set B has in A, B, C, both of them having 3 members, not so? So they are equivalent, but they're not equal, meaning they don't have in the same members, right? So you see this sign for equivalent. The three dash, like equal sign. So, and the example is given, set A is the set 1, 2, 3, and set B is the set ABC. So set A is equivalent to set B. That means they have the same number of members. So if in this class we have 15 males and 15 females, then the set of females, set F, is equivalent to set N. Right? Complement. You see this stroke above the A? That means complement. All the elements that do not belong to set A. Let me give you an example of a complement using this class. So the whole class has a male and female. So what is the complement of the set of females in this class? Which members do not belong to the female group? The males, so the males are the complement. Are you with me? You get it? Those that do not belong to the group are the complement, and together the female and the male make the whole class. So that's what complement means. Relative, you don't normally, you hardly use this sign at CXC level, right? But you could write it two ways with the slash. A is relative to B, or you could put a dash in between like that. Okay? The next one is an element of or is a member of. So common A is a member of set A. Common A belongs to set A. So the capital letter is the set and the common letter is the member. And when you have a strike through, it's not a member. And when you put the capital letter in prison bars, it is the absolute value. And if you look at the example, you will see the number of elements of set A. That is the value of set A. It's 3, because 3, 9, and 14. So the value of set A is 3. That means it has 3 elements. The empty set, you can make a strike through in a circle, or you can use 2 curly brackets and don't put anything inside. Empty curly brackets represent the empty set. You don't need to use both of them. Any one of them, right? That or that. So an example of an empty set is given people over 300 years. You wouldn't find anybody to go in that stage because you don't have them alive except it's a zombie. And the last one is the universal set. Set of all possible values. The universal set is usually defined. You are told what is the universal set. So if I say the class is the universal set, we can have all set of subsets from that universal set. We could have the set of females, we could have the set of males. We could have the set of people wearing glasses. That's 3 of us, 1, 2, 3. And the set of people not wearing glasses. Those are you all. You could have the set of grubby hair and the set of straight. You could make a lot of set, right? We ain't gonna say ugly and pretty and handsome. Because everybody is pretty and handsome, right? Okay. So that's it for the signs. I expect you to know them. If you don't know them, please don't. Let's go on to the next slide now. What is a set? The definition says a set is a collection of objects, usually of the same kind. Each set can be denoted by a capital letter. A set may be defined by listing the members or describing the members. So you can define a set by listing the members or describing them. So if I'm going to list the members of this class, I'm going to write the 30 names on the board in curly brackets. Right? So I have Jim, I have Tom, I have Harry, right up to 30 of them, and then I close the curly bracket. That is listing the members. That tells you, that describes the set, right? Or you could say, if you don't want to list them, you can describe them. And you say, set of PSU math students. That's your all in. So it's a description, or you can list them. I'm continuing through. A set is said to be well defined when all the members can be listed. Example, a flock of sheep is not well defined. Why is a flock of sheep not well defined?
Nothing specific.
Right, it's not specific. Because you might have a flock of sheep and you have 10 in the flock. I might have a flock and I might have 5. Somebody else might have another flock of 20. So when you say a flock of sheep, you don't know exactly how many. Are you with me? So that is not well defined. Prime numbers between 5 and 17 is a well-defined set. So prime numbers between 5 and 17. You remember what are prime numbers? Well, you have to revise. You have to know those things. Those are primary school stuff. A prime number has 2 factors only, itself and 1. Let me give you an example of prime numbers. What is the first prime number? Is 1 a prime number?
Yeah.
How many factors 1 has? 1. So it's not a prime number. So 2, the factors of 2 are 2 times 1, right? Then what? We just said 1 is not a prime number, right? The first prime number is 2. The next one is 3, because the factors of 3 are 1 on itself, 1 on itself. Those are prime numbers. The factors, the 2 numbers that multiply to give you the number are the factors. So all the numbers in the number system that only have 2 factors are prime numbers. Is 4 a prime number? No. How many factors it has? 3. It has 1, 2, and 4, right? Good. So 4 is not 1. What about 5? Yes. 5 is a prime number. It's 5 times 1, itself and 1. Is 6 a prime number? No. 7. Yes. 7 and 1. 8. No. 9. No. I hear yes, I hear. No. How many factors 9 has? 3. It has 1, it has 3, it has itself. So 9 is not a prime number.
11.
Okay?
11.
The next one is 11, right? And so on and so forth. Okay? You all have to know them, because those are the kind of questions they ask. Alright, so let's go back to the question now. It says, where was I? Prime numbers between 7 and 17 is a well-defined set. And we're going to count in 5 and 17, inclusive. So the first prime number between 5 and 17 is 5. What's the next one? 7, 11, 15. Oh, 13 and 15. 15. What? I tried to trick it in. 17. So that's a well-defined set because it has a definite set of numbers. How many members in that set? 5. 5 members or 5 elements. So this is a well-defined set. You can list them or you can describe them. To describe these numbers, it has been given on the paper. The set of prime numbers between 5 and 70. That's a description. That's a listing. Everybody with me? Yeah. Alright, good. Each item in a set is called a member or an element. Okay, types of set now. One, for a particular problem, universal set is the set from which all the elements are taken. The universal set is denoted by the symbol U. Well, capital U, right? So anytime you see that symbol, it means universal set. So if I write this on the board, I am giving you the numbers that we are considering. That's the universal set. So whatever you do must come out of this. This is the parent set, right? And you could make smaller sets, subsets, multiples of 2, for example. Multiples of 2. We could take them from there. So we go 2, 4, 6, 8, and we stop because universal set is whole numbers from 1 to 10. That's the description of this set. This universal set represents whole numbers from 1 to 10. And then whatever you do down here has to come out of up here. So that's how universal set is. Okay? Then you have the null or empty set, contains no element, is denoted by the symbol as 0 with a strike through. Example, if Z is the set of people on earth who are older than 300 years, then Z is an empty set. That is, Z is curly brackets or the 0 with the strike. Number 3, in a finite set, it is possible to count and name all the elements in the set. Example, the set X equal to days of the week. And that is the description. If you list it, you'll have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So the number of elements in set X is 7. Now this is a sentence, you know, and you have to be able to read it. A small n, round bracket, capital X equals 7. That is a sentence. Translate this to English. The number of elements in the set X is 7. Just as it is on the paper, set X contains 7 elements. Everybody okay with that? Yeah. Alright. Number 4. In an infinite set, it is not possible to count or name all the elements in the set. Example, set Y is the set multiples of 2. And so if you want to list them, you begin with 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. And you would go on and on and on and on to eternity. Right? So it's an infinite set. So the number of elements in set Y is unknown. We say that Y is infinite since the series is continuous infinite. Number 5. If A and B are two sets and all the elements of A are contained in B, then we see that A is a subset of B. Right? A is a subset of B. And an example is given. A is the parent set. No, A is not the parent set. A is the subset, 9, 11, 13, and B is the parent set. And B is 7, 9, 11, 13, 15. And you could see 9, 11, and 13 are found in B, but B has more members. So A is a subset of B. And C is the set 1, 2, 3. Then A is a subset of B. And it is written A horseshoe B, where the symbol horseshoe means is containing or is a subset of. Also, C is not a subset of A, and you have the strike through. Alright? Now I'm going on to union. You can form the union of two sets by joining them together. The symbol for union is horseshoe, not U. Remember, U is for what? Universal. The horseshoe is for union. And union means it's a joining, just like as it means in English. Example, if A is the set 2, 4, 6, and B is the set 1, 2, 3, 4, then A set A union set B is the set 1, 2, 3, 4, 6. So you join them, join up all the members in set A and set B. But notice you put them in order, right? Because it will be easier to understand rather than if you have all of them mixed up. So from the smallest to the greatest. So that's a union. Remember, a union is the joining of the two sets. You need to understand these concepts. These three concepts below here: union, intersection, and complement. If you don't understand these, you're not going to understand anything we're going to do after that. If you understand these, half of your problems in set is solved. Okay? So make sure you understand what a union is, what an intersection is, and what a complement is. So let me go through this again. Union. You have set A is the set 2, 4, 6, and set B is the set 1, 2, 3, 4. And then we say A union B. There is a union of A and B. That means you are taking both of them and make one big set. Right? So it's like you have a football club and a netball club, and you join them together and make a sports club, right? We don't call it football and netball anymore. We say a sports club. It's a union of the two. So 1, 2 belongs to both. You don't have to list it 2 times. It just means the same person belongs to both groups, right? So you don't have to put a 2 here and a 2 there again. It's the same person. If you in a football team and you're on a netball team, it's one person as well, but it's just one person in 2 different teams. So 2. 3 is in B only. 4 is in both, so you list it 1 time. And 6 is in A only. So that's the union of these 2 sets. That's the union of these 2 sets. Are you with me? Now it says to show this on a Venn diagram. Okay. Now when you draw a Venn diagram, we normally draw a rectangle, a box, to represent the universal set. The universal set. Now, we are assuming that these two sets come from numbers from 1 to 6, you could say. That's all? Because the lowest number is 1 and the highest number is 6. Right? So we could say 4 numbers from 1 to 6, right? So, what you do, you have to look to see if they are intersecting. That is to say, if the same members belong to both of them. Do we have any intersection here? 2 and 4. So that means you have to draw this. We use circles for subset. They are intersecting subset. That's the intersection, right? So if they were not intersecting, you would say they are disjoint. I don't want to rub off that. So you draw your universal set, and they are disjoint. If there is no intersection, are you with me?
Or you could say like no commonalities.
No commonality, right? So they are disjoint. But they have commonality, so you would make them intersecting. Then you have to label. This one is the universal. You can't just draw them and leave them, so you have to say which one is set A and which one is set B. So you say set A and set B. And what you do, start from the highest number and proceed up to this last one. Now, some people begin from in here and they go out there, but it's better if you go in an order so that you don't miss any. Are you with me? Practice yourself to go from the lowest one, and when you get here, you will have covered all of them. So, now you have 4 areas in this universal set. This area here, I'm going to show you 4 different areas. Well, this is looks like that. Now, how would you describe this area in terms of A and B that I just showed? Outside of A and B, right? Neither A nor B, right? Agreed? Right. So that area is called neither A nor B. What is this blue area called? Is this A? Is that part of A?
Yes.
A and B. This is A and B, right?
Yes.
Right, so it's A. If it's A and B, it's A and it's B. So you can say this is A only. Now you all remember these names, you know, very, very, very important. Very extremely important. A only. I'm going to shade here in what color is it? Orange? What color is it? That's one. A and B. Or A intersect B, right? A and B means A intersect B. And these are intersections. And this one out here, that's B only. So you have 4 areas. Anytime you're doing a Venn diagram, there are 4 with 2 subsets. CXC stop giving 3 subsets to make the exam easier. When I did CXC, I had to do 3 subsets, but then it's too complicated, so they cut it out of the exam. And you only deal with 2 subsets now. They make it so much easier. So, when you're doing 2 subsets, you will have 4 areas to consider. Neither A nor B, that is everything outside A and B. You will have A only, or you could say A but not B. You will have A and B as the intersection. And you have B only, or you could say B but not A. Are you with me? Write them down if you have to, because you have to, bound to and compelled to know these names and understand them. Alright? Okay. So now, we're going to put all these members in one of those 4 areas. And I want you to tell me where to put it. But remember the names, you know. Because if you tell me A, I can put it here or I can put it here. Because all that is in, as well. So you have to tell me exactly where to put 1. B only. Huh? Yes. So I put it somewhere in this region, right? Where to put 2? Yeah, intersection. A and B. Where to put 3? B only. Where to put 4?
Intersection.
Yes.
Subset.
Where to put 5?
Outside.
Outside. If you tell me outside, I put it outside.
In the shaded area.
What is the name of
Complements.
Eh?
The Venn
It's the
diagram.
complement. Neither A nor B. Yes, it's the complement. So you put 5 out here, right? Out there is neither A nor B. You get me? Or A and B complements. Outside A and B. And 6 is where? A only. And once you go from 1 to 6, your diagram is complete. You see how easy it is? So just go in the order from the smallest, go up to the largest, and when you get up there, the diagram is complete. Put them in the right place. Alright? So from this, you should understand complement. Because this is the complement. Are you so late to me? Okay. So when we say A intersect B is the set 2 and 4. And that is right there on the diagram. And then we say A complement all the members outside of A. You could look at it at the Venn diagram.
5.
Is 5 alone outside of A? 1, 3, and 5 are in A complement. That means they are outside of A. Are you with me? Is 1 outside of A?
Yes.
Is 3 outside of A?
Yes.
Is 5 outside of A?
Yes.
Well, that's A complement. Everywhere outside of A is A complement. So 1, 3, 5. Let's do B complement now. 5 and 6. Alright, and then what else can we do?
Complement of A and B. A union.
Pardon me?
A complement of A and B.
Complement of
A
A and B complement.
Yes.
Okay. A and B means A intersect B, right? This is all I'm going to give us now. A intersect, I wasn't going to give you that yet. A and B means A intersect B. Complement. Complement of A and B. That's what he said. That's what he meant?
Meant, yeah, that's all.
Okay. So you tell me what the answer is that.
That will be 6, 1, 3, and 5.
I was going to give you your classes fee off if you get it right, but you got it wrong. I mean for this for 1 month, not the whole thing. Is this question, Lord? Is this question? What is the answer? I'm giving all you the challenge.
But you see,
and you lose it
you
because
see, I have a problem with that. I have a problem with that because when you say intersect, right? I always say A union B. So it's neither, you know, but you say
All right.
intersect,
Okay.
so that's why I got confused.
we are dealing with the complement, right?
Mm-hmm.
Complement means outside.
Outside.
But outside of what?
The intersection,
What is the intersection?
2 and 4.
Right. So everything else is outside.
1, 3, 5, and 6.
Yes.
That's what I said.
It's still a part of. It's still a part. Number 12 is still a part.
Say right.
That's what you said?
Yeah.
That's what you said?
Yeah.
Okay, well, he's right. 1, 3, and 6. 1, 3, and 6. 5, and 6. Okay. That's correct. That is A intersect B, all complements. Well, I wasn't ready for this one because I wanted to take you in stages, but it's okay. And you all understand it. Okay, now let's go down to complement. The last one on the page. The complement of set A contains all the elements of the universal set that are not in set A. That is, the members missing from set A. The symbol for A complement is A/, that's sign in. And the example, if the universal set is the set 1, 2, 3, 4, 5, and set A is 2, 4, then A complement will be 1, 3, 5. And you have to show that on a Venn diagram. So you could do that for homework, right? That's it for this sheet. So let's go to the second sheet now. Second sheet. Everybody has it.
I think that got extra 20 cents.
Yeah, that's why those guys in the back didn't get from it. So, based on what we just go through there, we're going to answer these questions. State whether each set is finite or infinite. Y is a set of odd numbers. Yes. B. Prime numbers less than 10.
Finite.
Yes. C. Days of the week.
Finite.
Correct. D. Even numbers.
Infinite.
Correct. And E. Multiples of 3.
Infinite.
Good. So I'll finish those quick, boy. Now the number of subsets that can be obtained from a given set is 2 to the x power, where x represents the number of elements in the given set. So for example, if set A equals the set PQR, set A contains 3 elements, so the number of subsets that can be obtained from set A is 2 to the third power. 2 to the third power means 2 by itself 3 times. 2 times 2 times 2 equals 8. Do you understand that?
Yeah.
Some people do, not everybody understand. The number of subsets in any set can be found by using the formula 2 to the x power. That's the formula for finding number of subsets that can be formed from any set. As the formula. What does x represent in the formula?
Q.
X represents, x is a power, but huh? The number of elements in the particular set. Are you with me? Everybody's still not there. Some people not focusing. So let's take the same one that is given. If you are given the set A, which is P, Q, and R, you are being asked how many subsets can you make from this set? And that's the answer. 2 to the x power, where x represents the number of elements in this set. How many elements in this set? 3. So in this case, X represents 3. X is the unknown, right? We just don't know what it is. But now we have this set, we know it's 3. If it was a different set, we'll just see how many members and we know what X is. Are you with me? So you just put in 3 up there. 2 to the third power doesn't mean 2 times 3. It means 2 by itself 3 times. So you have to multiply 2 by itself 3 times. That's 1 time, 2 times, 3 times. And that's 8. That's all? So the number of subsets we can make from this set is 8. And I'm going to prove it to you. So we're going to make the sets. Now every set has the empty set and itself as a subset. Okay? Just like every number has 1 and itself as factors. All the numbers in the number system have 1 and itself as 2 factors. Some of them have more than 1 and themselves. And they are composite numbers. If they only have 1 and itself, they are prime numbers, right? So in sets, 2 subsets of any set is the empty set and the set itself. So I usually begin with the empty set. That's a subset of this set. And the set itself is a subset of the set. So we already have 2. We say we want 8, right? So give me another subset of this. Okay. I'm going to PQ is correct, right? But I want to do it in order. When you do it in order, you understand better and you don't miss. So give me a set with 1 member. Alright, set P. Q, set. This is set Q, right? Set Q. Now if you say Q, I don't have to write the curly bracket. But if you set Q, I have to put the curly bracket. You with me? Give me another one. Right, set R. Now give me a subset with 2 members. Set PQ. Give me another one. Set PR. And give me another one. Set QR. Do we have any more? Do we have 8 subsets up there?
Yes. QP.
QP is the same as PQ. Is that the same people? So you will tell me RP and you tell me RQ. So we have 8 subsets. 1, 2, 3, 4, 5, 6, 7, 8. So that's 2 ways of finding the number of subsets. You can list them or you can use the formula. Right? So if they ask you to write, if I give you the set, set X is the set 1, 2, 3, 4, 5, 6. You think you're going to list those for me? You're going to get real problems, you know. Because how many subsets you have to give me? Use the formula. The number of subsets in this one
6
would be x to the what?
6
to the what power?
6.
2 to the 6th power. That's all? Which is 2 times 2 times 2 times 2 times 2 times 2. You could work it out on a calculator. It's a big number.
64.
64. 2, 4, 8, 16, 30 to 64. So you have to make 64 subsets from this. Are you with me? So that's why I tell you, you must go in order. So you begin with, which force do you begin with? We're going to do this with you this evening now. If you want to try it at home. Empty set and the set itself. Always start with those 2, right? Then all the subset with 1 member. So you have this one by itself, this. All the subset with 2 members, you have this. You have 1 and 2, you have 1 and 3, you have 1 and 4, you have 1 and 5, you have 1 and 6. Are you with me? Yeah. Then you have to do 2 and 3, 2 and 4, 2 and 5, 2 and 6. Then you have to do 3 and 4, 3 and 5, 3 and 6. And then you do 3 members, right? And 4 members, 5 members. You already have this set itself. And you get all these subsets. But that is something that you do when you go home and sit down and try it, right? But I give you the formula how to know how many subsets. Everybody with me? Yeah. Okay, good. So let's go back to number 2.
6.
Number 2 says, state how many subsets each of the following sets has. List all the possible subsets of each. Now the listing I want you to do for homework, but for now we're going to see how many subsets in set A. How many subsets? That's the members. How many subsets can you make from set A? 5? I bet it's not 5. No, you're answering how many members in set A. That's not the question. How many subsets can you make from set Y? The members are A, E, I, O, U, vowels, right?
13.
How many subsets can we make from that? It is 2 to the 5th power, that's all?
Yeah. 2 times 2 times 2.
2 to the 5th power. Number of subsets. Are you with me? So you're going to get 32 subsets from that. And what I want you to do for homework, try to list the 32 subsets. Get some clean sheet of paper and just practice. Okay, but don't try it now. B now. How many subsets would you get from B?
4.
Yes, because that would be 2 squared. What about C? Yes, 2 to the 4th power is 16. And D? Right, good. So I told you how many. So now when you go home, you practice finding the subset by listing them, okay? Give yourself the practice. Now let's go on to number 3. You are given the universal set. Describe the universal set for me, please. Whole numbers. Right. And set A, what kind of numbers are set A?
Even numbers.
Even numbers. Or you could describe them as multiples of 2. And what are set B? Set B are not the set of odd numbers.
Multiples of 3.
Multiples of 3, right? Okay. I'm just asking you to describe them just to help your understanding, right? Now you are asked to list using curly brackets the members of A intersect B.
6.
A intersect B. You have to look at set A and look at set B and see which ones are intersecting.
6.
Right, 6. Just 6. Do we have any more? No. Right. So A intersect B equal to the set 6. And if you just write 6, that's wrong. You have to put it in curly brackets. That's part A. Part B now. A union B. A union B. Alright. We have 2, 3, 4, 6, 8, 9, 10. And close the curly bracket. Everybody good? Yes. Okay, we're going on to C. Now C asks for a complement. Those that are outside of A. Let me write up A and B. Alright, so tell me. A complement. One. Are you missing something? 3, 5, 7, 9. Alright. Good. Remember, if you miss the 3, you're going to get that one wrong, eh? If you miss any one, or if you put in something that shouldn't be there, you'll get it wrong. It's not going to be right. D asks us A, B, C, D for what? B complement.
One, two, 4,
4,
5,
5,
7,
7,
8.
8,
Close bracket.
and 10, right? Remember the universal set say whole numbers from 1 to 10. So to find set B complement you have to look at B, right? And to find A complement you have to look at A. Okay, we're moving on. Now we want the intersection of A and B. A, set A. No, this is A intersect B complement. We should have done, we missed A intersect B. That was the first one. Oh, we have it up here. Okay, A intersect B, all complements. Yes. 1. Everybody get that? What is outside the intersection? This is the intersection. If you want to find what is the complement of the intersection, you have to look at the intersection. That's all? Right, Johnny? Okay. F. A union B complement. A union B, all complement. The complement of the union. Call the bracket, yes. What do you have to look at to get the complement of the union? You have to look at the union, that's all? Because you want what is not in here. To get the complement. You following? Yeah. So you have to see what is missing from it. 1 is missing. 5 is missing. 7. 1, 5, 7. So that's it. E, F, G. G asks for A complement intersect with B. Now we're getting complicated. There is an intersection between A complement and B. So you're going to look at A complement, which is this. This is A complement, right? And this is B up there. This and this are intersecting. So tell me. No, intersecting mean they have the same members. Which ones are the same in those two? 3 and 9. So you say 3, call the bracket 3, 9, 2. Everybody there? No, let's go again. So let's start from the beginning. What are we looking for? What subset are we looking at? A complement and B. So we are looking at A complement and B. And what operation we're looking for? Intersection means belonging to both a complement and B. So which ones belong to B and also in a complement? 3 is intersecting, 9 is intersecting, right? So that's it. Everybody there? Huh?
Yes.
Alright. Now I want you to try from each. And I'm going to take the roll like this. Let me see what they're going to come up with. And say your names on me, please. Dion Benji. You said 6, right?
No.
2, 4, 8, 10. Alright. I know. What does I say?
A complement union.
A complement union with B. So we are looking at A complement and B. But this time it's a union, it's a joining. So you're joining everybody into one. Right? So tell me. 1, 3, 5, 6, 7, 9. That's it. 1, 3, 5, 6, 7, 9. And you're good to go. J. J says A union B complement. A union B complement. You are joining A with B complement. You are joining up these two. So tell me.
1,
1,
2,
2,
4, 5, 6,
1, 2, 4, 5, 6,
7,
7,
10,
after 7 is what?
8,
8,
10.
10. That's it? Alright. K is A complement intersect B.
B complements.
There is an intersection. It is between A complement and B complement. So you're looking at these
1.
two here. But you're looking for an intersection.
5.
You have 1
And 5.
and you have 5.
7.
7. 1, 5, 7. 1, 5, 7. Close. Now I run out of space on the board, so I'll just call out the answer, right? H-I-J-K-L is the last one. A complement union B complement. So you're looking for a union between these two. You are joining up these two. Alright? So tell me.
1,
1, 2, 3, 4, 5, 7, 8, 9, 10. And that's it. You are good to go. Now the next part of the exercise is similar. You are asked to find n, a small n, a round bracket, E. So what that is telling you, number of elements in set A. Are you with me? That's what this is saying. How many elements in set A? If you list them, you are saying you don't understand what the question is saying. It's just like you go to the doctor and the doctor asks you, what is your name? And you say, I am 17 years old. Right? You answering a question that wasn't asked, right? It's not saying to list the members like this. Are you with me?
Yeah.
This is a different statement. This is telling you to make the union of A and B. But this is asking you how many elements in the set A. So what do you have to do? Tell me what you have to do. Count them. Count them. How many elements in set A? Look, set A there. So all you do is write 5. Now if you put 5 in curly bracket, it's wrong. 5 in curly bracket is saying the set 5. It's not asking you for no set. How many in set A is 5? Are you with me? Okay. So let's go with these. So all of these just giving you the number. How many in set B?
3.
Good. The next one. How many in A intersect B?
5.
How many in A intersect B? Look at 20.
1.
In other words, you have already done this, so all you have to do is count n. Right? The number in A intersect B is 1. Everybody understand what we're doing here?
Yeah.
Alright. The number in A union B. 1, 2, 3, 4, 5, 6, 7. Alright, so you get the answers, you just count them as we go along. It's the same thing we have done already. So you just have to count them and put in the number. So what I want you to do, students, for homework, is to complete this, put in all your numbers, then you do number 4. Number 4 is similar to what we have numbers. You have a set using numbers. You have the universal set using letters. And it's the same question, but it's just a different situation that is given. So complete number 4 for homework. And then if you can go on to the back page, you can do so. Right? But I want you to finish the front page, everybody. And those of you who can go on to the back, you can do. But if you don't go, it's okay. But everybody must finish the front page, okay? And we'll continue on set next week and all.